Watch out out. Shout out. What's out sa what's out? What's out? Cotabato. Watch out. Shout out pala, shout out.
Example number 1. The driver of a car, traveling at a certain speed, suddenly sees an obstruction ahead and traveled a distance of 58.3 meters during the reaction time of 1.3 seconds. Determine the car's speed of approach in kilometers per hour. In this problem, we are asked to determine the initial speed VI of the car right before applying the brake. The problem states that the car traveled a distance of 58.3 meters during the reaction time. Since the distance traveled during the reaction time is given, we can conclude that 58.5 meters is the lag distance given at the reaction time of 1.3 seconds. Now, for lag distance, we can use the formula lag distance is equals to initial speed multiplied by the reaction time. Since the initial speed is unknown, we can rewrite the equation as initial speed is equals to lag distance divided by the reaction time. Then substitute the known values to the equation. Initial speed is equals to 58.3 meters divided by 1.3 seconds. We will obtain 44.85 meters per second or 161.46 kilometers per hour. Therefore, the car's speed of approach is 161.46 kilometers per hour. Example number 2. A driver traveling at 50 miles per hour is 80 meters from a wall ahead. If the driver applies the brake immediately after perception time of 2 seconds and begins slowing the vehicle at 10 meters per square second, find the distance from the stopping point to the wall. In this problem, our goal is to determine the distance x from the stopping point of the car to the wall given the initial velocity of 50 miles per hour or 22.352 meters per second, total reaction time of 2 seconds, and acceleration of 10 meters per square second. It was stated also that the driver is traveling 80 meters from the wall ahead. We can conclude that 80 meters is the total sight distance, which is equal to stopping distance plus distance x. Since distance x is unknown, we can rewrite the equation as x equals to 80 meters minus stopping distance, where stopping distance is equals to lag distance plus braking distance. For step 1, we have to determine the lag distance given the initial velocity of 50 miles per hour or 22.352 meters per second and reaction time of 2 seconds. Using equation lag distance equals to initial velocity times total reaction time or 22.352 meters per second multiplied by 2 seconds, our lag distance is 44.704 meters. After obtaining the lag distance, we have to determine the braking distance given the initial velocity of 22.352 meters per second and deceleration of 10 meters per square second. Since the car has stopped, its final velocity is equal to 0. Using kinematic equation Vf squared equals to Vi squared plus 2AD, we will have 0 squared equal 22.352 plus 2 times negative 10 times the braking distance. Therefore, we will obtain braking distance of 24.98 meters. Since the lag distance and the braking distance are already known, we are now able to compute for stopping distance. Now, stopping distance is equal to lag distance plus braking distance. So, stopping distance equal to 44.704 meters plus 24.98 meters. Therefore, stopping distance is equal to 69.684 meters. We can now solve for the distance x after the stopping distance of 69.684 is known. where x is equal to 80 meters minus the stopping distance, or x is equal to 80 meters minus 69.684 meters. Therefore, the distance x from the stopping point of the car to the wall is 10.316 meters. Example number 3. A car moving at 80 kilometers per hour on a level road suddenly sees an obstruction 76 meters ahead. If the perception reaction time is 0.5 seconds and the coefficient of friction between the tires and the pavement is 0.4, how far from the obstruction will it stop? In this problem, again, our goal is to determine the distance x from the stopping point of the car to the wall, given the initial velocity of 80 km per hour or 22.22 meters per second, total reaction time of 0.5 seconds, and the coefficient of friction of 0.4. It was stated also that the driver is traveling 76 meters from the obstruction ahead. We can conclude that 76 meters is the total sight distance, which is equal to the stopping distance plus distance x. Since distance x is unknown, we can rewrite the equation as x is equals to 76 meters minus stopping distance, where stopping distance is the lag distance plus the braking distance. First, we have to determine the lag distance given the initial velocity of 80 km per hour or 22.22 meters per second and reaction time of 0.5 seconds. Using the equation lag distance equals to the initial velocity times the total reaction time, or 22.22 meters per second times 0.5 seconds, we have lag distance of 11.11 meters. After obtaining the lag distance, we have to determine the braking distance given the initial velocity of 22.22 meters per second and the coefficient of friction of 0.4. Using equation for braking distance equals to Vi squared divided by 2 mu g, or braking distance equals to 22.22 squared divided by 2 times 0.4 times 9.81, we will have braking distance of 62.91 meters. Since the lag distance and the braking distance are already known, we are now able to compute for stopping distance. Now, stopping distance is equal to lag distance plus braking distance. So stopping distance is equals to 11 meters plus 62.91 meters. Therefore, stopping distance is equal to 74.02 meters. We can now solve for the distance x after the stopping distance of 74.02 is known, where x is equals to 76 meters minus stopping distance. So x is equals to 76 meters minus 74.02 meters. Therefore, the distance x from the stopping point of the car to the wall is 1.98 meters.